All right. Sorry, guys. I'm getting this set up. Okay. Hi, guys. So we're going to be working through section 252 today, which is an extension off of something you did last year, where you talked about what was called regression. So you did a whole unit on statistics in Math 1, where you took a data set, you created a scatter plot, and then you determined what an appropriate model would be for a data set. Last year, you really focused on linear and exponential models, and this year, with the focus being on quadratic functions, we're also going to mix in quadratic functions for our models. So our goal for today is use regression to create an appropriate model for a set of data. Before we get there, why don't we take a look at the homework from last night? So here's the answers to the homework assignment we had. So if you guys want to open up to that page and check over answers. So remember we were talking about growth and decay with exponential functions. So these were the answers we should have gotten. Pay special attention to the exponents in 3, 4, and 5. So we had to first raise the number inside the parentheses to the exponent, and then convert that to our rate. Those are the answers to 1 through 5. 6, the initial population was 440 deer, the initial value in the exponential function. Then 7, it wound up being a decrease or a decay of 8%. 8, okay, decreasing at a rate of 4% for wolves. Deer, higher rate, decreasing by 8%. Then 9, initial value was $4,000. 10 should have gotten approximately 1% growth. Okay. All right. So today we are going to work on using a calculator. It's going to be a review from last year to build a scatter plot in our calculator and then determine what the appropriate regression model would be. Okay. So we are on page 137. You might have to check the page number. That might be off from yours. But go to section 252, open up to example 1. Okay. Then let's talk through how to input data into our calculator. So we use the stat menu to do that. So we can click on stat. Okay, the stat button in the middle. Nice thing with a video, you should be able to pause and do exactly what I'm doing on here, following along with your graphing calculator. Then hit edit. You should have nothing in here. If you have anything in here, you can, like if yours said, I don't know, 2, 3, 4, then you could physically scroll up and delete these entries, okay, one by one, or you can hover over the list and click clear and then enter, and it'll clear everything out. If you hover up here and accidentally hit delete, notice it does delete your list, which we don't want to do. The way we can get that back is we click stat, go down to set up editor. If you ever accidentally do this, hit enter, and now when we go back into our stat menu, list 1 is back. Okay. So if we look at example 1, it says Lena wants to look at the relationship between the weight of a car and the gas mileage of the car. She collected the following data on 10 cars. Okay, so we have really 2 variables here, right? We have our weight in pounds and we have our miles per gallon. Okay, so when we have a table like this, we can think of the column on the left as our x variable and the column on the right as our y variable. Okay, in terms of our calculator, we can put all of this into our list 1 and list 2. So we can start typing in entries. Okay, start with that. 100, enter, then 3,500. This will take a while on here. Enter 6,500. 4,000. 2,350. 1,800. Just typing all these in. You should be doing the same. Okay. We go over to the right right to list 2, and we type in our miles per gallon that match up, 30, 28, 15. Okay, so now all our data is in. So now we want to create a scatter plot in our calculator. So the way we do that, go into y equals. Let's clear anything out that's in there. Okay, so if you have any functions in there from previous problems, clear that out. And then let's go into this stat plot menu we see in blue. So we hit second y equals. Let's click on this plot once. Let's hit enter. So now it looks like this. My X list says list 1, my Y list says list 2. If you don't have this, okay, if they don't say this, you see in blue above stat where it says list, we could hit second stat to open up the list and make sure it says list 1 and list 2. Okay. So now if we want to display this, we can hit enter on. So now we turned on plot 1. If we just clicked trace, how we would normally graph, nothing's necessarily going to pop up. Okay, and that's because we haven't created a window yet to show these points. The nice thing with the statistics unit is our calculator can do this for us. We can hit zoom at the top. And then if we scroll all the way down to option 9, you probably remember this from last year, zoom stat, enter, and it creates this scatter plot for us. Okay, so let's just sketch this in our workbook right now. Draw scatter plots. I can do better than that. Come on. You don't need to necessarily put numbers on this. Let's just draw a sketch of what this looks like. Something like this. Okay. So now we want to look at it and we want to think what type of a function would fit this data. So these points look relatively linear in terms of they make a straight line. They do go up and down a little bit, but they're kind of oscillating all over the place. So this does look like a linear model would be the best fit. Now, if it made like a curved shape, then we could use an exponential function. If it made a U shape, we know a parabola is the U shape where we could use a quadratic model. But this looks relatively linear. So we want to perform a linear regression. Okay, so the way we would do that, we click the stat menu, go over to the right to calculate, and now we want to do a linear regression, that fourth option. Enter, and then we can hit enter. Yours might have more stuff pop up, but you can go down and click enter at the bottom, and it gives us this model. Okay, so this is going to be our model, and we can write this down, okay, where we have some space. Okay, so maybe we'll just write this off to the side here. Y equals negative 0.005 x plus 44.01. Sorry, you guys can make it a little bit neater than mine. Now, let's say we wanted to determine if this is a good fit or not. Okay, so I'm just going to go to a blank page here for a sec. Okay, let's talk about residuals. We talked about this in your math class last year. So a residual is, sorry, this is not right and great. A residual is the actual data value minus the expected data value. You're like, where is this expected data value coming from? The expected data value is from your regression model, right? We created this model that now is going to give you all these expected values for this function. So let's just draw ourselves a sketch of a scatter plot and talk about residuals. So let's say this was our scatter plot, something like this. And let's say we fit a line through it, a line of best fit. Well, now if we were going to create a plot of all the residuals, remember, it's the actual value minus the expected value. So in this case, the actual value is down here minus the expected value. You would be subtracting a number that is bigger, making a negative value here. So we'd start down here. Then this one, actual minus expected, would be a positive number. Goes back down here. Get something like this for our residual plot. So our residual plot is random. Well, a random residual plot would be good, right? Because this looks like a good model for this, right? It's going right through the middle of our data where we're kind of oscillating left and above and below. So if our residual plot is random, that means we have a good fit. And maybe this is ringing a bell from last year when you did your statistics unit. Well, let's think about what would be a bad fit. So maybe let's draw ourselves a graph or draw ourselves a scatter plot that's clearly a curve. Let's make it look like an exponential curve. Something like this. And then let's fit a line to it where it's not the right fit. Right? If we drew a line through this, that's not the right fit. This looks like it should be a curve. Okay. Well, if we looked at a residual plot for that and thought about where those points would be, and actual minus expected, we'd start above, then we'd go below, go even lower, coming back up. It makes this U shape. So a U-shaped residual. That means that would be a bad fit. So in general, when we have a random residual plot, then that means it's a good fit. When we have a U-shaped residual plot, that means it's a bad fit. Okay. All right, so let's go back to our data set. So now we have to think about how do you make a residual plot? Well, we have to set up our calculator to do that. So if we go back into our stat plot, so we hit second y equals, let's go to plot number 2. Okay, so we're going to go down here and we're going to set this up to show residuals. So now we're going to scroll down to where it says Y list, hovering over list 2. And then let's go into our lists. So let's hit second stat. And we see the 7th option down here where it says RESID, residual. So we hit enter there, hit enter. Okay, so now if we go back into our stat plot menu, second y equals, currently our scatter plot is on and our residual plot is off. Okay, so let's shut off our scatter plot and let's turn on our residual plot. Okay. The other way that you can do this is if we go into our just y equals, you see plot 1, plot 2, plot 3 at the top. Remember, we have plot 1 being our scatter plot, plot 2 being our residual plot. So if we had it like before, where our scatter plot was on, we could hover above it, hit enter to shut it off, and then go over to plot 2 and turn that on. The only other thing we have to remember is we need to make a window for this. So now we want to hit zoom 9 in order to do zoom stat to make a new window for our residual plot. Okay, so there's our residual plot. And let's draw that out. Draw a quick sketch of that. That's looking very random, which is good. We have a random residual plot. Meaning we have a good fit. Okay. So this model would be a good predictor for data. Okay. So this model would be a good linear regression for this data. So now it says, what would you expect the gas mileage should be for a car that weighs 2,700 pounds? Well, the whole value in this model is now we can make predictions. So if we wanted to estimate what the gas mileage would be for a car that weighs 2,700 pounds, we could put 2,700 in for X and see what we get. So let's do that. Okay, so we could say Y equals, write it down here, negative 0.005 times 2700 plus 44.01. Let's put that in our calculator. So we get 30.51. And then what are we measuring that in? Well, our y variable was the miles per gallon. So we can approximate that we're getting about 30.51 miles per gallon. Okay. All right. Let's try another one. Let's flip ahead. Let's go to example 2. Okay, so let's enter in this data set. Okay, so we can hit stat, edit. Now we want to clear out this data. Clear this out. Let's type in all these values. 0, 2, going on, putting all these numbers in. Typing in all these numbers. Okay. So now let's pull up a scatter plot. So we go into our y equals. We can scroll up top. Let's turn on the scatter plot and shut off our residual plot. So now yours should have plot 1 on, plot 2 off. Hitting enter on that to shut that off. Then we got to make a window. So we hit zoom 9. And we get this scatter plot. Okay. Draw in what this relativity looks like. Looks like that. Okay. So now we look at this, we see it's not linear, right? We look at this, we should be thinking this looks like exponential regression, right? It's making an exponential curve. So let's go into our stat menu, go over to calculate, and then if we scroll down for a while, scroll down, pretty far down, you should see one that says EXP-reg. It's option 0. Okay, so that's what we want. Let's do exponential regression. So now it's saying in the form y equals a times b to the x power, these are the values of a and b. Okay, so let's jot this down. Y equals 16.898, so we could say 16.90 if you're rounding to 2 decimal places, times 1.22 to the x power. Okay. So now let's pull up our stat plot, or sorry, our scatter, or pull up our residual plot now that we've done this regression model. So we have y equals, let's shut this off, turn on our residual plot. We want to make our new window for the residuals, zoom 9. Cool. It's looking random. That means it's a good fit. Draw in our points. Kind of all over the place. Okay, so we could say U shape, good fit. Okay. So we found our model that best predicts the data. Okay, create a residual plot. We did that. Estimate the wolf population of this region after another 10 years. Okay, so another 10 years, we can think of that as at year 32. Okay, so we're putting in 32 for x. So say y equals 16.90 times 1.22 to the 32nd power. See what we get. Approximately 9,803. Actually, if we round to the nearest, 804 wolves. Okay. One more. Let's go to example 3. Okay, so let's enter in this new data set. So we go stat, edit, clear this out, type in our points. Type in all our data. Okay, so now let's look at a scatter plot. So we scroll up here, turn on plot 1, shut off plot 2. Next, we want to show our scatter plot. Hit zoom 9, and we get this scatter plot. So let's draw this out. So this one starts going up and then it comes back down. So now this is looking more like a U-shaped parabola. Okay, so what type of model is most appropriate? We should probably try quadratic then. Right, so let's click stat over to calculate. A quadratic regression is option 5 here. Quadreg meaning quadratic regression. Okay, we should copy this down. So it's saying in standard form y equals ax squared plus bx plus c. These are the values of a, b, and c. So let's write this down. Approximate just to 2 decimal places here. Let's say y equals negative 0.35 x squared plus 20.63 x minus 104.14. Okay. Let's check and see if there was a good model using the residual plot. So we hit y equals, let's turn off plot 1, turn on plot 2, hit zoom 9. There's our residual plot. It's looking pretty random. U-shape, good fit. Sorry, not U-shape. Random, good fit. I think I might have, did I say that in the last one? Sorry, guys. I meant to say here, this is a random, not a U-shape. Sorry, guys. Realized that as I was going. Random, good fit. All right. So, where are we at? So we had a good fit here. So now we can use this model to make predictions. So it says use it to determine the number of employees that will produce the max profit. Well, this is going back to last unit, where X is our number of employees and Y is our profit. So producing the max profit, the number of employees, well, that would be really when we think of maximum or minimum with a quadratic function, we should be thinking vertex, okay, of this quadratic function. So to determine the number of employees, that's the x value of our vertex. That's the axis of symmetry. So we should be thinking opposite of b over 2 times a. So that'd be negative 20 -0.63 over 2 times -0.35. -20.63 divided by 2 times -0.35. So we get 29.47. Okay. Determine the number of employees that will have the max profit. So we could say 29 or 30 employees, or you can have a partial number of employees. Okay. That would be our answer there. Okay, so today we want to be able to make a scatter plot, look at it, see if it makes a line, an exponential curve, or a quadratic parabola, and then perform regression in order to interpret for questions. Okay. Our homework. Okay, so if we flip ahead to the practice problems section, okay, let's see. So we want to do these pages, practice 252, questions 1 through 10. So you guys can look in your textbook and make sure you have the right page number for that. So section 252, numbers 1 through 10. Okay, that's what I'm going to be checking in on Monday. Okay. All right. Have a good weekend, and I will see you guys on Monday.